class 11th, I will tell you about the state of equilibrium. So actually state of equilibrium is of three kinds. One, the stable equilibrium, second the unstable equilibrium, and third the neutral equilibrium. The state of equilibriums the states of equilibriums are of three types. One is the stable equilibrium. Second is the unstable equilibrium. And third is the neutral equilibrium. So first I take the stable equilibrium. Stable equilibrium. An equilibrium is said to be the stable equilibrium if the body is slightly disturbed from its position, then it regains the original position after the displacement. The body is said in stable equilibrium if it comes back to its original position after a small a body is said to be in stable equilibrium if it comes back to original position after a small displacement or a small disturbance. In it, अगर हम किसी बॉडी को थोड़ा सा डिस्टर्ब कर दें और बॉडी फिर पहली पोजीशन में आ जाती है तो इसको स्टेबल इक्विलिब्रियम कहते हैं. Now, if you take a cone, inverted funnel, this is now suppose like this. It is placed. This is the inverted. This is a type of toy that generally the infant child pushes it and then it is to goes down and again comes back and becomes vertical. That is a this is we can take the inverted funnel or you take a cup like this. This is now in this way. Suppose here is the ball and this ball is placed at the bottom of cup. If this ball is slightly disturbed, then this will come back. Similarly, if this funnel is slightly tilted, then it will come back. So, this gives you the example of this stable equilibrium. There are so many toys of the toys that have the stable equilibrium. In figures shown, a funnel or ball in a cup are slightly disturbed, they regain original position. तो अगर हम थोड़ा सा डिस्टर्ब कर देते हैं तो they will come back to the original position. Then this is called the stable equilibrium, and second the unstable equilibrium. Unstable equilibrium. Unstable. If a body is slightly disturbed from its position, from its new position, if a body is slightly disturbed from its new position, the body does not come back to its original position. तो अगर डिस्टर्ब करने के बाद वो पहली अवस्था में नहीं आती है, इन द इनिशियल स्टेट में नहीं आती है, देन दिस इज कॉल्ड द अनस्टेबल इक्विलिब्रियम. तो हम इसका जस्ट उल्टा करते हैं. जस्ट वी हैव द रिवर्स ऑफ दिस वन. सपोज वी आर हैविंग ए क्लास लाइक दिस. In this situation, or we are having a cup. This is now a ball placed here. Then what will happen? If you push it slightly, then this will goes down, or this will be tilted. Similarly, if this ball is slightly displaced, this will come down, or this will not come back to its this position. This is an inverted cup, ball only. On the bottom of inverted cup. Similarly, we are having this inverted funnel. Inverted funnel. If this ball or this funnel is slightly disturbed, then they will get a new position and they will not come back. So this is the example of the unstable equilibrium. In the figures, if funnel or ball, this is not ball, are slightly disturbed, they will not come back. So they are in unstable equilibrium. It is unstable equilibrium. Unstable equilibrium. If suppose we have having the third one is neutral. In neutral equilibrium is what? That the body after displacement or after the disturbance that it gains a new position. If a body acquires a new position when when disturbed from its original position, If a body acquires a new position when disturbed from its original position, it is called neutral equilibrium. Neutral equilibrium. Suppose we are having a funnel, or we are having, suppose this is a ball. This is a ball here. If this is displaced from this position, then it will gain a new position. This will be a new position here. If this is like this one, then this will come back here. This will be here. This is the new position. This is the initial. And this is now final position. So the body is permanently displaced. Similarly, if you are suppose having a flask lying on the like this, if this flask is slightly disturbed, then this will get displaced permanently. In figures, the bodies, if disturbed, will gain a new position. Then these bodies are in neutral equilibrium. So the stable equilibrium, if the body gains the original position after the disturbance, and in neutral in this unstable equilibrium, the body is displaced, then not gaining to the original position, and in the third, the neutral one, the body is always goes to the new position, and this is not coming back to the original one. So this is the kind of the neutral equilibrium, this is the kind of unstable equilibrium, and that first one was the stable equilibrium. So now you can have that what should be the conditions for the stable equilibrium, because all the physical system want to remain in the stable equilibrium. Conditions of stable equilibrium. Of stable equilibrium. First is the center of gravity. Of the body must be in lowest position. The center of gravity of the body must be in the lowest position, and second is the base of the body should be wide and heavy, because when the body is heavy, the series will be in the lowest position, and this is not wide one, then this will be very difficult to disturb it, so this will remain in the stable equilibrium. So these are the two conditions for the stable equilibrium. Now in this year, a question was asked in the NEET exam 2021. Question in NEET 2021. Now what was there? That this was a beam of 200 centimeter long. This is not 200 centimeter long. This is the peg here. This is no, this peg is like this one, not like this. This is not peg. This is as a mark of 40 centimeter. 40 centimeter. Here we are having a body of mass m. This is not a body. This is not body. Here we are having this now 0, and this is now 200 centimeter. And this is at a point of 20 centimeter from here. Now this mass of this body is the 5 kg, and this was at 20 centimeter. 20 centimeter. Then there was given another body. This is now its mass is to be found out, and it was given at 160 centimeter. 160 centimeter. From this peg, no, from this 0 position. Then it was the question that what should the value of m so that this beam remain in the equilibrium. So definitely now this distance is 20 centimeter from this peg, and this is now your 120 centimeter from this peg. Now take the moment, the moment of this and moment of this, that will be equal and opposite. M1G R1 equal to M2G R2. So now you can see that this M1, this is now your 5 into G, and this R1, that is now your 20 centimeter. This is equal to M2. This is now your G, and that was now 120 centimeter. So now G and G will cancel, and you can see that this M2 equal to, this is now your 5 into 20, 5 into 20 upon 120. Now this 0 will cancel, this will cancel by this is now 6 times. This is so much. You know 6.5 kg. This must be of so much mass of this body M. So for the equilibrium, this is necessary that the moment of these two bodies about this peg, that must be equal and opposite. So now we are having this relation, and from this one we have to find this M2. So this will come out to be so much. This was the answer. So a similar question may be asked. Either this may be from the theoretical part and this may be from the numerical part also. So this is about the statics, because this was necessary to tell you, because the question may be asked any of the exam, whether this is in the your what we call the competitive exams. So you solve the questions like this and find that what is the value of the unknown weight or the some unknown distance from the fixed peg. So thank you very much.